Hello everyone! In this video I will present your work entitled A Heuristic Approach for Dual Expert and User Evaluation of Guidance in Visual Analytics, in which we describe a methodology to evaluate the effectiveness of guidance approaches, both from the point of view of visual analytics users and visual analytics experts. Let's start from the beginning. As we all know, visual analytics can be used to get insights out of the data. However, sometimes performing such analysis can be complex. In particular, errors may occur and different types of uncertainties can affect the whole process, limiting our ability to get to the end of the analysis. For these reasons, analysts typically resolve to use guidance during the analysis. The use of guidance can help to reduce the problems arising during the analysis and make the analysis successful. In the past, we already characterized guidance and analyzed different factors affecting the guidance generation process. However, how to evaluate the effectiveness of guidance in practice remains an open challenge. What does it mean that the guidance was effective for the user? Does it mean that it improved their performance? Does it mean that it improved their overall experience? Similar to what happens for visualization approaches, their effectiveness depends on many different factors. What we want to do in this work is to abstract the general characteristics that contribute to the effectiveness of guidance, and subsequently derive a methodology to evaluate those characteristics in practical scenarios. So we come to our contributions. In this work, we identify 8 qualities or criteria that contribute to the effectiveness of guidance. In order to be effective, the guidance has to be flexible, adaptive, visible, controllable, explainable, expressive, timely, and relevant. Having identified those criteria, we derive 2 sets of heuristics to evaluate and quantify the effectiveness of guidance in practice. Why do we derive 2 sets of heuristics and not just one? We realized that certain aspects of guidance could be better judged after having experienced the tool and received the guidance in the first place. For example, to check if the guidance was provided on time or helped in getting out of problematic situations, it makes sense to refer to users who actually received the guidance. In the same way, we realized that experts, for instance, designers, could better assess other criteria from the first stages of development without needing to actually experience the tool. As our last contribution, we describe a protocol and provide templates to evaluate guidance in practical scenarios. This is the methodology that guided our research. Our research can be structured in 4 subsequent phases, in which we increasingly refined and improved our methodology. In the first phase, we focused on understanding the meaning of the word effectiveness in the context of guidance. So, we performed a thorough literature review comprising evaluation approaches. The result of this phase was a set of more than 100 terms and words, which we eventually reduced to our final list of 8 quality criteria. In parallel to the literature review, we also sent out a set of questionnaires to ask visualization experts their opinions about the effectiveness of guidance. In particular, we asked them to provide at least 3 words that they mostly associated with effective guidance. Thanks to these terms, we created a similarity graph and merged them with our previously created list of criteria. Afterwards, we showed them our list of criteria and their definitions and asked for feedback to assess if they could properly understand them and agreed with them. In the following phase, we created 2 sets of heuristics. As already mentioned, we realized that some characteristics could be better judged after having experienced the guidance, while others could be already judged during the design phase. We also formulated the heuristics in different ways. For simple users, we limited the use of technical words specific to guidance and we formulated them using the first-person singular. For experts, we introduced specific terminology and formulated the heuristics as rules of action. And this is the result we obtained. 8 effectiveness criteria. 27 heuristics for visual analytics users, 18 heuristics for visual analytics experts. If you want, you can check them using the QR code here on the side. In the last phase, we worked to assess how our heuristics worked in practice. For these reasons, we designed 2 additional user studies, one involving 5 visual analytics experts and one involving 39 visual analytics users. For the expert evaluation, to simulate the real usage of our heuristics, we employed them to evaluate a prototype of a guidance-enriched tool under development. We recruited 5 experts and showed them 6 videos recreating 6 analysis scenarios. The scenarios featured different characteristics of the guidance. For instance, the guidance had no explanations. In some scenarios, it was delayed, and in one scenario it provided irrelevant suggestions. The guidance was also adapting to the context and, in general, it was able to provide multiple types of suggestions. We showed these videos to a group of experts and then asked them to evaluate our expert heuristics using a 7-point Likert scale. The outcome of the study is visualized in this table. In the columns you can see the different criteria and in the rows the different ratings. Columns are also sorted according to the average rating. In summary, the experts identified and evaluated correctly the different guidance features. The explainability of the guidance got the lowest ratings. The relevance got mixed ratings. Experts praised the adaptiveness of the suggestions, and also visibility and timeliness of the guidance were assessed in a positive manner. With the user evaluation, we wanted to check the coherence and reliability of the given answers. For this evaluation, we enrolled 39 visualization participants and used an existing guidance-enriched visual analytics system, Data Voyager. We asked the participants to solve a simple exploratory task, such as getting a comprehensive sense of the dataset's content. Then, we asked the participants to answer the user version of the questionnaire with the heuristics. In summary, the participants assessed positively the guidance provided by the system, much in line with the original evaluation described in the paper by the authors of Voyager. However, thanks to our methodology, we can obtain a much broader picture of the effectiveness of the approach. For instance, the participants reported that the guidance was appropriate for the task, but the analysis burden was completely on them. If they made an error, the system could not help them solve it. The adaptiveness of the guidance received low ratings, as the system can adapt only according to the data selected by the user but not according to the needs of the users or past interactions. The control of guidance received mixed ratings. The participants reported that they could not fine-tune the guidance or provide feedback. The explainability of the guidance had positive ratings. The participants could understand why guidance was provided to them, and this, in turn, increased their trust in the system. However, they noted that in case something was not clear enough, they could not ask for additional explanations. We also ran a quantitative evaluation of the results obtained. In particular, we applied Cronbach's alpha measure to assess the reliability of the heuristics and the consistency of the provided answers. The results obtained are very encouraging, and they tell us that the responses were consistent. This implies that our methodology is reliable and that the quality criteria we identified are not redundant. We also asked an additional group of experts to evaluate the Voyager system using expert heuristics and then compared the results with those provided by the users. From the results, we could see that both groups of evaluators rated positively the relevance of the guidance, as well as assigned mixed ratings for its timeliness, controllability, and explainability. 4 out of 5 experts did not notice problems with the adaptability of the guidance. However, problems were detected by the users. This means that it could be possible to improve the design of this guidance aspect. Moving to the discussion, we can say that our heuristics can provide a comprehensive assessment of the effectiveness of guidance-enhanced visual analytics systems. As we have seen, the effectiveness of guidance depends on multiple factors. Currently, each of these criteria is rated equally by the heuristics. However, some of them could be more important than others. This opens the possibility for alternative scoring systems. We created the expert heuristics using specific terminology. However, during some initial tests, some experts were confused by the terms used because they were not familiar with them. Hence, we want to point out that it could be easy to make errors and obtain unreliable results if the experts are not familiar with guidance. Additionally, we created our heuristics by applying a bottom-up and a top-down methodology. This was done to minimize the risk of missing some effectiveness criteria. Finally, we identified the crucial aspects contributing to the value and effectiveness of guidance. In particular, 8 criteria and 2 sets of heuristics for experts and users to evaluate guidance in practical scenarios. Thanks for your attention.